Hey everyone, this is BremSter, and today I'm going to attempt another puzzle from Quads on Parade called Drookit by Pesto. I don't understand the name on this one, but whatever. These puzzles are all being recorded out of order just as they're coming up in my list, and then at the end we will sort them by what we believe the difficulty is and release them in difficulty order, because that's the way we roll. So I will find out about it as I'm solving. So let's have a look at the puzzle. So normal Sudoku rules apply. So in every box, in every row, and in every column, the digits 1 to 9 get placed without repetition. We have quadruples, so digits in circles. Those digits must get placed at least once in the 4 cells touching the circle. So 2, 4, and 7 will get placed in those 3 cells, and we must place at least 1 3 in those 4 cells. There could be 2 3s, but there will be at least 1. Similarly, there will be at least 1 4 and at least 1 9 in those cells. There may be doubles. Like that is distinctly possible by the quadruple rule. Do not know. We'll find out. Then we've got counting diamonds. So a digit in a diamond equals the number of times that digit appears in diamonds. So if there was a 2 in this cell, then we would only ever have 2 2s in diamonds anywhere in the grid. That's the way the rule works. So I'm going to restart the puzzle to restart my timer. Let's give this a shot. Now, we know these are 2, 4, 7, and 8 because they are what can go in there. But there is an interesting thing about counting diamonds, and I'm never sure. I've only solved a few puzzles with these, but people tend to love them. So the way it works is how many diamonds do we have? So if we do this, actually, there's an easy way of counting them, which is if you just put 1 in them, the sum tool on the app will tell me that there are 17 diamonds in the puzzle. So because there is a tool in Sudoku Pad that gives you the sum of all of the digits that you've selected, and I did that. So there are 17 digits in the puzzle. Now, if I was to, so that means I am basically making a unique sum of 17. It's like a killer cage of 17, because if I put 9 9s in here, then the other digits have to be made up of other digits. So I can't repeat digits when I make up the 17. So how am I going to make up that 17? Now, I have to use I have to use 2 of these digits when I make up the 17. Now, the fact that I've got 2 in each cage is interesting. I have to use at least 1 of 1, 2, 3. I can't use... no, I'm not sure. I really don't know about how this one's going to work. 17. How do you make up 17? I can't put a 9 into diamonds. Because if I was to put a 9, let's get rid of the colouring. No, not the pencil marks, the colouring. If I was to put a 9 into diamonds, I would need to put a 9 into diamonds in each box. And I can't do that because I can't put a 9 into the diamonds there. And I can't put an 8 into diamonds, because if I was to put 8 into the diamonds in here, maybe I can. I would need to put 8 8s into diamonds. Now, I could put 1 in this box. I couldn't put an 8 into a diamond in this box, because if I put an 8 into a diamond in this box, this would be 2, 4, 7, 8. This would be 2, 4, 7, 8. And those 3 cells there would have to be 2, 4, 7, and 8. That doesn't work. But could I put an 8 in all of the other boxes? This would be an 8, so this would be an 8. This would be an 8. There'd be an 8 down here. This would be an 8 because I couldn't put 1 there. This would be an 8. This would be 1, 2, 3, 8. That might work, you know. I'm not sure. I can't put 7 into diamonds. Right. These quads are telling me I can't put 7 into diamonds. Because the way these quads are working is they are going to form There must be a 7 in one of those, and there must be a 7 in one of those, which means that because there are 2 sevens taken up in rows 8 and 9, one on this quad, one in this quad, I can't put a third 7 into rows 8 and 9. Oh, actually, I might be wrong about that, because I could put a 7 there and then just not in those boxes. And then I'd have a 7 here, a 7 here, a 7 here, and then I'd need to get 7 into all the other boxes. And I could do that. That could be 7 sevens. No, it can't be. Because how these two and these two would prevent me from putting 7s. Right, if I was to put right, I can't put 7s into diamonds. Because of this, I couldn't put 7 into any of these two. So I'd need to get 7 into 7 boxes without being able to use box 7 or 9. So I'd have to put one here. And then I'd need to get one into all of the other boxes. That's the only cell I could put it in box 5, which would put it there. That means that I'd have to put one here, and now I can't put a 7 around here. There is no 7 in diamonds at all. Can I disprove 8? There'd be an 8 in here, there'd be... Can I disprove it? Yeah, I couldn't put 8 in here because, as I said, this would now then be 2, 4, 7, 8. So I need an 8 in every box except box 1. So this box couldn't have an 8 in diamonds. So there would be an 8 here, an 8 here, an 8 here, an 8 here, an 8 here. An 8 in one of those two, an 8 in one of those two, and an 8 in one of those two. And that doesn't work because that breaks that quadruple. There is no 8 in diamonds. That's very clever. So these are 2, 4, these are 7, 8. And there is a 2 and there is a 4 in diamonds. But there's only 2 2s in diamonds and there's 4 4s in diamonds. Now that's 6 of my, 17? Yes, because there's 2 in 8 boxes and then an extra one. So there's 17. So that's 6 of my 17. So I can't put 9 in. Actually, did I confirm that? I don't think I confirmed that at all. Because 9, 9, 9, 9, and then I couldn't put 9 around this quadruple. There's no 7, there's no 8, there's no 9. But I still need 17. I need 17 without 7, 8, or 9. So all of the diamonds, so 7 is in one of those two, so 7 is in one of those two. 8 is in one of those two, 8 is in one of those two. Okay. And that was the point of that clue and these clues. That's very clever. Still haven't figured it out though. Still need another 11. How do I do that? I could just use 5 and 6 maybe. 2, 4, 5, 6 would get me there. But there's other ways of making 11, I'm sure. Like 1, 3... I don't know. 1, 3, 5... Actually, maybe not. Because I'm making 11 from the digits 1, 3, 5, 6. Because I've already used 2 and 4, and I can't use 7, 8, or 9. So I've got to make 11 from those digits. I can't, 1, I can't use 2, 4, 1, 2, 3, yes, you already used 4, 5, 6, can't use 7, 8, 9. So I have to make 11 from those digits. It has to be 2, 4, 5, 6. Because if I use, while I can use more digits than that, how else do I make 11? Because if I don't use the 5, I've got to make 5 from 1 and 3. That doesn't work. There's no other way of doing it. If I use the 1, I need to make 10 from the other digits, and 3 and 5 and 6 and 5 doesn't get me there. The total is above 11. If I don't, so I can't use the 1. And if I use a 3, the other digit would have to be the other digits would have to, it just doesn't work. This is, so the circles are 2, 4, 5, 6. That's amazing. So these are all of the circles are 2, 4, 5, 6. So this is a 3, 8 pair. This is a 1, 3 pair. So 3 is up here, not there, here. The 2 around this quadruple, that's not a 2 because of this quadruple. Two, 4 is fine. 7 is off. Two can't be there. I've already got 1, 2. I can only put one more 2 into the diamonds. Okay, so I need to get 6 6s in. Only using these boxes. So only using those, I need to get 6 6s in. I don't see a problem there. Because I've got 9 rows, 9 columns, and 8 boxes to play with. Now 4 has to go around here. And it can't go there. So 4 is in one of those 3. Eight is in one of those 3. There's going to be something about the disposition of this I don't understand. Because while I get 6 6s in, I've also got to get 5 5s in. But 6 and 5 don't appear on any quadruples. I was pretty happy just figuring out 2, 4, 5, 6, but I don't know what to do with it. I've only got, no, 2 is on down here because 1 and 3 isn't. So 2 is absolutely in one of those, and 2 is in one of those. So I can take 2 out of all of these. These are only 4, 5, 6. So this is a 2, 7 pair. And there must be a 4 on here. So I've got 2 of the 4s already. This can't be a 4 because 4 is up here and 4 is up here. That one can't be a 4. So that's one of the 5s and 6s. This is now a 4, 5. Now I've got triples. Maybe I can colour. So let's get rid of all of the yellow. So one of these is a 2. 2 is in one of those 2, by the way, because 2 is up here and 2 is down here. 2 is up here. I'm not sure what that's... but 2 can't be in any of those because there's a 2 around here and there's a 2 around here. So 2 can't be in those, 2 can't be in those. 2 has to be in those. That's been a 2 from the very beginning, but I didn't see it. I'm allowed to make mistakes, though that wasn't a mistake. It was just not seeing something. But These are 4, 5, 6 triples. So let's call this yellow, this blue, and this green. Now, no, actually, I'm going to do this slightly differently. I'm going to select all the 4, 5, 6s. Mark them in yellow. And I'm going to give this one also purple. There must be a 4 in here. There must be a 4 in here. There must be a 4 in one of those, and it can't be there. So there's a 4 in one of those two cells. Like, I can see these are green and purple, but I can't see the order. But there must be a 4 here. There must be a 4 here. There must be a 4 in this column. No, that's not true. There must be a 4 in this row. But if that's a 4, it takes the 4 in that triple and in that row. And then I would be able to place another 4. But if this is a 5 or a 6, none of those are 4s. Including those. If that's a 4. Okay. There's something I'm not understanding. There's something I'm not understanding. It's got to be the 4 around here, doesn't it? 4 isn't here. 4 is in one of those. If 4 is here, 4 can't go in the middle. So 4 would go here. And then I would need to put another 4 here, and I'd have all the 4 in diamonds, and none of these could be 4. So that would be a 4. Hang on. If 4 went... I can't put 4 here. Because then 4 would go here. I couldn't put a 4 in a diamond here. Because I'd have 1, 2, 3. I'd have to put a 4 in one of those two, because this wouldn't be a 4. That couldn't be a 4. That would be a 4. I can't put a 4 here. 4 is in one of those two around this. Can I put a 4 here? Because these would be 5, 6. Sorry, there was a potential 4 here. If I put a 4 here, these are 5, 6. Yeah, all I know is that can't be a 4. There's something going on with 4s, and I don't understand it. If this is a 4, because one of these two is a 4, if this is a 4, then I've got 1, 2, 3. I only get one more 4. And it's in one of these spots. But if this is a 4, then I can't put a 4 down here. Because if I put a 4 down here, I've got no 4 on a diamond in this row. So I couldn't put a 4 down here or down here. So 4, if this is a 4, where do I put 4 down here? 4 would have to go in those and those, but not in those. Oh, I'm stumped. There was... Oh, it was really cool how I was able to figure out what they were. 1, 2, 3, 4, 5... 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and there's a 4, a 5, or a 6 down here with a 2. 15. That's correct. Is it, how do you get 6 sixes in? Like, where does this go? But I'm playing with 1, 2, 3, 4, 5, 6, 7, 8 boxes. So if this was a 6, that would... I don't have to make any of these a 6. I have to make maybe 2 of these a 6. But I only have to make 2 of them a 6. So then I start saying, well, if this is a 6, that's a 5, so that's a 4. But then I'm really into weird bifurcation territory, and I don't like it. Oh, this is a 2-7 pair. Because 2 is up here and 7 is up here. 2 is up here and 7, and I can't put them in there. This is 2-7. This is not the 4. This is the 4. So now I've got 3 4s placed, and I can't... Right. This is the 4, because I couldn't put 4 in here. This is a 2-7 pair. That's the trick. Because now, if I was to put a 4 in this column and a 4 in this row, I'd have... So if this wasn't a 4, I'd have a 4 here and, say, a 4 here. Or even if it was those two. 1, 2, 3, 4, 5. I'd have 5 4s. It doesn't work. That's a 4. So these are not 4s. And I've got 1, 2, 3, 4. I've got all the 4s. So none of these are 4s. So this is 5 6. This is 2 5 6. But that's a 5 6 pair, making that's the trick. That's the trick. And I didn't see it. So let's uncolour those. 4 is in one of those two now. So this is purple. This is purple. This is green. So this is purple. This is yellow purple. Green is up here. But I'm not sure. Well, this is green. This is purple, because these can't be the same thing. So they're different colors. So this is green. I need something to see both green and purple. This is purple. So purple in box 5 can't be in any of those or those two. This is yellow purple and a 5 6. Yellow green is in one of those two. I'm not sure how to mark that. It's in one of those two. 4. But 4 is now in one of those two. So 4 is not down here and 4 is in one of those two, because I can't put 4 here or here. In fact, I can't put 4 there. That's the 4, which makes that the 2. That 2, of course, looks up making that the 7 and that the 2. The 7 looks across making that the 8 and that the 7. The 2 makes that the 4 and that the 2. That means that's not the 4, that's the 4, and this is now green. Ha ha! Oh, that 2-7 pair. Beautiful. Absolutely stunning. Took me too long to see it, but that's okay. 4 is down here. So, where is purple? That's purple, because I can't put purple in either of those. So that's yellow purple, which is 5, 6. I think I'm just going to get rid of all the yellow at this point, because I'm just using green and purple. So this is purple, because I can't put 5, 6 in there. So this is 5, 6. And have I got all the purples? 1, 2, 3, 4, 5. Yeah, I do have all the purples. So green can't be in one of those two. So green can't be down here. So where's green in this row? It's not there. This is the green 5, 6. And now green in this box is in one of those, and it's in one of those two. So that's where the 5, 6s end up. Right. This is a triple. 1, 3, 9. This 8 is looking down, making that the 3 and that the 8. The 3 looks up saying that's not the 3. 3 is in one of those two, which puts 3 in here. The 2 is in one of those two because of that 2, which puts 2 up here. 2 is down here. Okay, there is still something I don't understand about this puzzle. These are 1, 3, 8, and 9. No, I don't. But, no, it's going to be colours on circles. I'll be able to get the 5s and 6s because I've got 1, 2, 3, 4, 5 green diamonds and 1, 2, 3, 4, 5, 6 purple diamonds. Purple is 6 and green is 5. That's so cool. And I can get rid of all of the colouring. Haha. I made progress. Should have thought of that earlier. Didn't. So 8 is in one of those two. 2 is in one of those two. So now I'm kind of just down to quadruples because I've done all the diamonds. Okay. Now I'm terrified. What have I missed? 3, 3, 3 is in one of those. Okay. Now let's look at the digits I've got a lot of. Have I placed all the 6s? Yes. Have I placed all the 5s? No, but I can place more because that's a 5, so that's a 4. This is now a triple. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are 7, 8, 9. Now there's no 8 there. I don't know about 7 because 7 might be able to go there. But now these are 1 and 3. So 1, 2, 3, 4, 5, 6, 7. These are 8, 9. And that looks across, making that the 1, taking 1 out of there. This is so cool. 3, 9 means that 9 is in here because I can't put the 9 down here, taking 9 out of there. 3 is still in one of those. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 3, 8, 9. So 8 is in one of those two. No 9 in any of those cells. That's the 9, which makes that the 5. What does that do? Well, 2 here and 2 here means that's the 2, so that's the 7 and that's the 2. Now, the 1 looks back, making that the 3 and that the 1. These are now 1, 2, 3, 4, 5, 6, 7. These are 3, 8, and 9. But there's no 9 there. There has to be a 3 in one of those two because of the 1, 6. So that's not a 3. So there's no 3 here, but there has to be a 3 in the box. There's a 3 in one of those two. What are these? 1, 3, 7, and 8. So these are 1, 7, and 8. I'm not sure what to do with that. Oh, this 3 is making that the 1 and that the 3. Which does put 3 up here. This triple, 1, 2, 3, 4, 5, 6, 7, and 9. 2, 7, and 9. Well, there's no 2 there because the 2 has to be down here. The 9 makes that the 7, and I can take 7 out of those. These are 2 and 9. The 2 makes that the 9. That becomes the 2. That's not the 2. That's not the 9. This is a triple. 1, 2, 3, 4, 1, 4, 7. The 7 says there's no 7 there. The 4 in the row says that's the 1. This becomes a 4, 7 pair. So we know what this is. 1 and 8, 2, 3, 4, 5, 6, 7, 9. These are 1 and 8. So these, 1, 2, 3, 4, 5, 6, and 9. There's a 4, 9, so that becomes the 3. This is and the 4 here makes that the 9 and that the 4. So this is a pair. 1, 2, 3, 4, 5, 1 and 8. This is a 1, 8 pair. And the 1 looks up making that the 8 and that the 1, which makes that the 9 and that the 8. This is a triple. 1, 2, 3, 7, and 9. There's no 9 there. 7, hang on. There's 7 and 9. That's the 3, so that's the 7 and that's the 9. Take 7 out of there, making a 1, 8 pair. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the 3. So this is 1, 7, 8, and it's not 7, neither is that. That's the 7. This is a 1, 8 pair. Wow. These are 3, 7, and 8. That 3 says that's not the 3. That's the 3. This is a 7, 8. If that's a 7, the 7 is down there and in there. That seems okay. No, yeah, no, that'd be okay. I think. This 2 is looking down saying that's not the 2, so that's the 2. This triple, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 1, 8, 9. Well, there's no 1 there. There's no 8 there. These are 3, 8, 9. I've got the 2. Putting an 8 around here is not going to be that tricky, I don't think. If that's a 1, that's an 8. That's a 9. That's a 1. I don't think that forces that. If that's a 1, that's an 8. That's a 7. 7 goes down here and down here. That's all fine. It's an 8, 1, 8. That all looks okay. There might be something around here, but I think I need another digit around here to force it. So 1 has to go somewhere in this column. So it's 1, 2, 3, 4, 5, 1, 7, 8, 9. These are, oh, there's no 5 there. That's important. That's the 5. That's the 3. This is 1, 8, 9. Does that do anything? Yeah, the 3 makes that the 9 and that the 8. I should have seen that. That's the 8. There's no 8 there. The 8 looks down, making that the 7. Now I need to put an 8 around the quadruple and it goes there. That's the 8. That's the 1. That's the 1. That's the 8. That's what I missed. I was looking in the wrong place. The 1 looks up, making that the 9 and that the 1. The 9 looks down, making that the 8. There's no 8 there. The 7, 9 makes that the 8, or I could have used the 7. This is just a single. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 1 and 4, which I can resolve with the 1. So 4 and 1. The 4 makes that the 7 and that the 4, and the 7 makes that the 9 and that the 7. And I've made a mistake. I've made a mistake. I hope that was just a pencil mark entry error, because one of those is a 3 and it's that one. That is the correct solution. I'm hoping that was just a typing mistake when I entered that. Yes, that was just a typing mistake. So just running that back through and put the 3 in at the end. So, yeah. And it took me 33.32 by the look of it. So 3s were the theme of me messing up on that puzzle. That was brilliant. Figuring out what digits had to go in the diamonds was stunning. Yeah, I like that one. Thanks, Math Pesto, for the puzzle for the pack. Really do appreciate it. Where it's going to go in the pack, I don't know. I think this is a bit of a hike. So, yeah, over half an hour. This is probably mid-range hike. But, yeah, we'll see how the others rate it as well. Thanks, everyone, for watching. Hope you're enjoying the pack. And as always, good luck with your solving.